Okay, so this is lesson 4. Solving quadratic equations by factoring. In this lesson, we're going to see how you can use factoring to solve quadratic equations. So thus far, we've been looking at quadratic expressions. If I put an equal sign on it, now it's an equation. An equation that can be put in the form ax squared plus bx plus c equals 0 is what we call a quadratic equation. Notice I'm just saying it can be put in that form. And again, a cannot be 0. We'll be utilizing an extremely important concept called the zero product property. 0 is a very unique number. If two numbers multiply to 0, one of them has to be 0. Or, in other words, you would get 0 as long as either one of them was 0. This is true for no other number in all numbers. For this reason, and for other reasons, ancient civilizations that had a concept of the number 0, like Mayans, Aztecs, the Arabs and the Indian continent, these ancient peoples had a concept of 0, were just much more mathematically advanced than their counterparts. So 0 is powerful because of the zero product property and a few other things. Let's solve the following quadratic equations. So here's what we're going to do. We're going to factor them first. We're going to get them equal to 0 first if they're not. Then we're going to factor them. Okay, so the equation's equal to 0. We're good to go. Always look for a GCF first. I don't have one, so I'll factor like so. X and X, and then I'm going to put, so you got to multiply to 7. Got to be the same sign, that sign, so we'll do minus 7 and minus 1. So according to the zero product property that says if A times B equals 0, then A could equal 0 or B. So here's my A, and here's my B. If these two things multiply to 0, then either one of them being 0 makes the equation true. So this is me using the zero product property. Now I'll solve this equation by adding 7. I'll solve this equation by adding 1. Let's check our work. Now, we could check the original equation, but why don't we just check the factored version? Is that a true statement? Well, what's 7 minus 7? 0. 7 minus 1. I really don't care what it is. It doesn't matter because 0 times anything is 0. Let's try the other one. 7 minus 1 and 1 minus 1. Again, I don't care what 7 minus 1 is. It's 6 in this case, but it doesn't matter because 1 minus 1 is 0, and anything times 0 is 0. So it's real easy to check my work. Now, if I go back to the original one, it'd probably be a little more complicated.
Wait, how did you get, so you just, oh, never mind. You just took each parentheses and equal it to 0.
All right, let's go to the next one. We have to have the equation equal to 0. Factoring does not help you unless it's equal to 0. So let's do that first. I'm going to subtract x squared from each side, giving myself a 1x squared on the left. I'll subtract 9x from each side, making this minus 9x. And then I'll subtract 16 from each side, giving me a negative 10. That's right, just moved everything to one side. Now I'm going to factor x and x, and I'm going to call this a minus 10 and a plus 1. Now that I've got it factored, I can solve this by simply setting each factor equal to 0. This is the zero product property that we're using. So x equals 10 and x equals negative 1. And we should be putting our answers in set notation, and I realize I failed to on the last one, so I'll go back and do that. Not points, not parentheses, that's for points. This is set notation. Let's do letter C. First things first, I've got to set it equal to 0. All right, now I've got it set equal to 0, I can factor it. This factors as x plus 10 and x minus 2. Then I can use the zero product property. Since it's factored and equal to 0, I'm able to say this is true. And I get x equals negative 10 and x equals positive 2. Either one of those values, when put in for x, would cause this to be 0 times something, and 0 times anything is 0. So our solutions are negative 10 and 2. All right, let's try the next one. I'm going to set this equal to 0 as well. And we'll factor. So I got 3x and x. That's the only thing that could equal 3x. Now with the 5, it's the only things that multiply to 5 are 1 and 5. So it's either going to be 1 here and then 5 here, or 5 here and 1 here. Well, if I put the 5 over here, I'll get 5 times 3 is 15. So that's what I'm going to do. Then I'll set each factor equal to 0. And this is a good moment for me to point something out. Sometimes students get in such a hurry, they start seeing these patterns where the answer is always like this one's negative 5, and they'll jump over here and think, oh, that must be negative 1. Not so, because of the 3 in front of the x. Make sure you solve it properly. Divide by 3, it's a negative 1/3.
Is it always going to be like this, or are there times when it doesn't work?
So the question is, will I always be able to factor? No. But in this lesson, yes, unless I messed up, which is very possible. So it turns out that just in general, a quadratic expression, if this whole room was full of quadratic expressions, I could probably hold in my hand all of them that were factorable. I mean, but because of just the very nature of the way problems are developed, we end up, we're not just factoring problems out of no context whatsoever, out of the context of how the problems come about, be they lengths and widths of things or from a calculus problem, they end up being factorable an incredible amount of the time. So yeah, I have to hand select problems that are factorable. We'll develop ways to solve these without factoring in the next lessons. But today, factoring. So, give practice 4.2 a try. Okay, so to solve a quadratic equation, we must set it equal to 0 if we're going to use factoring. So, I'll make this 0 equals y squared minus 2y minus 8. And that will factor as y minus 4, y plus 2. And then setting each factor equal to 0 gives me y equals 4. And y equals negative 2. Okay, the next one, again, to use factoring to solve a quadratic equation, it only helps to be equal to 0. So let's subtract x squared from each side. I'll subtract 12x from each side. And I'll add 1 to each side, making this 2x and x for the first part. And I know it's 2 and 1, just where do they go? Let's put the 2 over here so I get a 4x and a 1x. If I make them both negative, that'd be a negative 4x minus 1x, negative 5x. And then we'll just set each factor equal to 0 with our 0 product property. So x equals 1/2. And x equals 2. So 1/2 and 2. All right, we'll take a look at the next one. 3x squared minus 9x equals 0. So it's already equal to 0. That's good. That part's done for us. We do have to factor it. I'll factor out a greatest common factor of 3x. Remember, always check for GCF first. Then I'll set each factor equal to 0. So this 3x will set it equal to 0, and this x minus 3 will set it equal to 0. Remember, factors are multiplied. I know this one looks weird because it doesn't have parentheses, But that's just because the parentheses aren't needed, because there's no plus or minus. But if it makes you feel better about yourself, put parentheses around it. So x equals 0 when I divide by 3, and x equals 3. Both of those clearly would work, right? Because plug in a 0, you get 0, and that's times something is 0. So 0 and 3. And as a general rule, if you have a quadratic equation equal to 0 and every term has an x in it, 0 must be an answer. Because if every term has an x in it, then every term would have a 0 times it, so it would just go away. All right, let's look at letter D. Okay, I'll distribute 4x minus 8. And then we're going to set it equal to 0. So x squared minus 10x, then plus 9, because I added 8 to each side. And this factors as x and x. Right, numbers that multiply to 9, because it's a plus, they need to be the same sign, so they're going to add. So numbers that multiply to 9 and add to 10 are 1 and 9. So minus 1 minus 9. Which, if you do the process, you'll get x equals 1 and 9. No, no. Doesn't matter. Order doesn't matter. All right. Now, this next one's frustrating because you see on the left it's factored, and you're like, oh, yeah, it's factored, but it's not equal to 0. This one's clearly not equal to 0, but even if it was factored and equal to -1, you would have to expand that out, move the numbers over, and redo it. So it's just the way it is. So let's FOIL this. X times x is x squared plus 2x minus 3x minus 6. Okay, so now I got to get all my x's on one side. I'm going to move them over to the right so that I have a positive x squared. So I'll subtract x squared from each side. Subtract 2x. Oh, but this makes a negative x, so I'm going to add an x, actually. Then add 6.
Wait. No. Yes.
All right, I'm going to go back, and I'll just simplify this first. X squared minus x minus 6. Like that.
Wouldn't it be 4?
Okay, I got to subtract x squared from each side. I got to add x to each side.
6x. Why did I do that? Okay.
And then add 6 to each side. And then this becomes x plus 5 and x plus 1. So x is a -5 and a -1. Okay, the solutions to a quadratic equation are often called roots. So roots are kind of like a special title that we give to solutions of quadratic equations, as well as some other ones. It comes from we talk about the square root of a number, so it's the root of it. So it's got a square in it. All right. So an example 4.2, if you're getting the habit of just multiplying everything out, you might actually end up making this more work than it is. It's already factored. Sometimes it just is. It's already factored. It's already equal to 0. Just set each factor equal to 0. Couldn't be easier. So x equals 0 and x equals -3. All right, on letter B, it's already factored, but it's not equal to 0, so it doesn't do us any good. We have to unfactor it. 5x minus x squared equals 4, and I don't like negative x squared, so I'm going to move everything to the right. So it becomes a positive x squared minus 5x plus 4. Yeah, we should put it in set notation. That would be good. Should always be putting our answers in set notation. Thank you. All right, then I can factor this as x minus 4 and x minus 1. So you're going to get that x equals 4 and x equals 1. All right, on letter C, I just really don't like negatives in front of x squared, so I'm going to divide both sides by a -1. making this a positive x squared, a positive 7x, and a minus 18, and 0 divided by negative 1 is still 0. And I'll factor. See here, I think I'm going to go with plus 9 and minus 2 because that would give me a negative 18. 9x minus 2x is 7x. So x equals 2 and x equals negative 9. All right, on letter D, again, hey, the hard work's done for us. It's factored and it's equal to 0. So I just have to set each factor equal to 0. X equals 1/3. X equals negative 2. All right, on the last one, it's factored, but not equal to 0. So it just does you no good. You got to multiply it back out. X times x is x squared, minus an x plus 2x, then minus 2. So that's x squared plus x minus 12 when I get everything combined and equal to 0. Now I can factor that as x plus 4 and x minus 3. So negative 4 and positive 3. Yeah, that's it. Okay, so that's the end of that lesson.